Okay, nice to see you on my talk in Vox Days Cluj. Napoca, I'm saying that correctly? Okay, cool. So, my name is Jarek Ratajski, and I'm developer, wizard, and an architect. As wizard, that I don't have to explain that, but maybe you don't know who is an architect. Who knows what an architect does? So if you have architects in a team, especially if you work for, I know, German customers, whatever, typical architect is the one guy that brings an order to your project, makes the rules, everything, the designs, and a lot of constraints. So if you have a lot of good architects in your project, one day you will find out that you can't do anything anymore because everything is like so well described and constrained that it's hard to write any single line of code because for sure it breaks some rules. So then comes an architect that is the guy that breaks the rules, simply. It's like I'm throwing away architects and that's my role. So if you are in one day in that kind of the project that you are blocked, then call me, I go there and kill your architects and bring chaos in your projects and finally you can do something. Okay, I live in Lucerne, that's a nice city over the lake, under the mountain. There is even a dragon, of course, and a lot of dwarfs there. I love the place. I work for Ingenious GmbH in Switzerland, working consulting from banks, insurances, etc. So really interesting stuff, fascination. And that's my Pokemon, so how I call them, especially this one. Still have like the assembly code for 6502 processor in my memory, so it's really not that much place for Hibernate or Spring or Java E left. That's a pity, but if you want to reach me, it's best to see me on Twitter because I mostly react to Twitters. On email, I answer like with 4 months delay. But okay, so before I even start my talk for real, it's like first I want to introduce the concept of multiversum. That's a concept like philosophical. Who has heard about this multiversum? Okay, so very, very short lesson. It's not perfectly correct. I'm not really like a scientist. So, you know what's this? Who knows? What's that? What's that? What is this? You've been to school, I hope. Some of you. What is this? Yeah, that's something called orbital. It's like if you see an atom. Okay, there is an atom here. Right now, I'm looking at it. Okay, it's right here. You don't see it, but it's very small. And there is a couple of electrons around it, around the core. So they don't really like make rounds or whatever. If you spot them, you might spot them in the one place. And this cloud represents the density, how probable is to spot the electron in one place around the core of the atom. So, for instance, it's might be that if you observe it, you will spot it right here, like here, or there. It's more probable, it's more dense, or here. But it's very unlikely to spot it here because it's like probability here is basically 0. So there's a problem with this randomness. Some guys say, do we really have in each atom like kind of machine, random machine that decides, or in electron where it is? It just doesn't look good even in equations. So maybe we don't like this. So a lot of scientists don't like this randomness. And they proposed the solution to that, and they said basically there is no randomness. Let's imagine that every time we observe something, and then we observe electron in one of this position, there is no real randomness, but what happens is something that we in IT know for years. Fork. Who knows fork? You know, when you fork process, you have basically 2 copies of a process. So let's imagine we've observed the electron here and we forked, and we live right now in this sub-universe, sub-process, but there is also another sub-process where it forked in a different way. So the electron was spotted differently. It's the same guy describing this talk, but he has spotted it here. So it's like the whole universe forked. And by the way, it's not only 2 possible solutions, you have like almost infinite possibilities. And so it's like uber fork, like super fork. And then, you know, after a while you do second observation and you see electron in other position, then you have like forks, and this is forked second time in all positions, so you have infinite right now possible solutions and possible stories, what has happened. In all of these words, there is one guy in front of you describing this story. Okay, but it's how it works. So let's imagine because of this one single electron, the whole Earth, whole universe is forking, And you know, in one of those universes, maybe the fork was yesterday, I was maybe drinking in the night, and I didn't even made it to the hotel, I'm somewhere else here, and I'm not even giving you this talk, so you don't learn this stupid concept right now. So this is really like interesting idea, and you know, the problem is in the world there is not one electron, so there are many of them, probably more than 1,000. I know, it's a huge number. So, because in each of them happens something in each possible moment, you have like massive multi-fork, like it's like forks of forks of forks. It's really hard to imagine, so like, if you look at universe, it's like forks of forks, this Uber fork, it's called multiversum, basically, this concept, that basically there is no randomness, we only, at one moment, I see the path that led me to this moment, but all the other possibilities exist. The thing is that we have no connections then. In the moment the fork is done, there is still no IPC, interprocess communication done, so we just don't know. Probably there exists something there, okay, there's a concept, but it's scientifically, this multiversum concept is totally useless. It's more philosophical thing because it cannot be verified scientifically. We can't, as long as we don't find this inter-universe communication is just useless concept, but it's funny. I wanted to describe you for that because I am a wizard, so I can do something with that. So now go back to the reality, real life case, okay? Forget about this thing. So there is a galaxy, I told you, real life. This galaxy is quite known in a couple of places. And there is a guy, the businessman in this galaxy. It looks like that. You know, it's not our galaxy, so it doesn't look like as a human totally, but it's a humanoid. So, and he is a businessman who he wants to run a galactic pizza delivery, galactic-wide pizza delivery. Cool, galactic-wide. So he describes a domain, his problem. He wants to have like serve pizza to 10,000 planets. By the way, there are more planets in this galaxy, but only 10,000 planets where they really eat pizza. That's like that. And basically he wants to make his business easy, so he creates 3 most important variants of pizza. He will deliver Hawaii, Margherita, and vegetarian, of course. And 3 sizes, medium, large, and extra large. You see one thing, he's a very smart guy. Nobody really would order small pizza, never. So it's like... And he wants to make it very easy, so his pizza delivery will be like having very easy interface. You just select the variant size and you press, bring me that to my planet. So for instance, so each order has only 1 pizza. So I can't order like 5 pizza. If I want to have 5 pizza, I have to click 5 times. It's like Tinder in pizza delivery. Bam, bam, bam. Okay. By the way, this guy is also very doesn't want to spend money that much, so he has only hired 1 pizza delivery boy, really 1, with 1 racket, and he wants to make it very efficient, so he has idea, whenever we will be serving this pizza, just pizza boy shouldn't really go according to the queue, to the orders, but should really serve the planets that demands most pizza first. Like, if there is a planet that awaits for 4 pizzas, he should go there. And if then there is another planet like with 3 pizzas, he should go there. Even though, for instance, this guy ordered first, but doesn't matter, his planet is like forgotten somewhere, better to make more money here. It's like this. So if you see the guy delivering pizza, so you get the idea more or less how it should work. So then he puts some other requirements. He wants this business to be very, very fast, like he wants to serve 10,000 pizzas per second. So it means like the system should be performant enough that 10,000 pizzas per second can be ordered and can be served by the pizza guy, delivery boy, is very, very fast. His racket is very fast. You know, it's Galaxy, they are very fast in technology. So the only thing that is limiting our system is like the software part. It should be fast enough to do that. And by the way, he would also want to see how many orders are in the queue, and he will be like, constantly checking, because he's really supervising his business 10,000 times per second. He wants to take a look at the system and see the number, and his wife also. So like two people looking constantly how many orders are in the queue. So what he did, typically what you do, he hired some alien creatures, so developers. The developers are always aliens, so it makes sense. Like, they look like that. You see a couple of juniors and the senior one. Okay, the one worried is a senior. Okay, but. And they've seen all this story about, the 10,000 pizzas per second, the 10,000 planet, and all of that. And they are thinking how they are going to implement that. So there is, and in this moment I'm getting with my magic, I've seen this solution in 2 parallel universes that forked. Not a long time ago, but they forked. So developers, aliens look more or less the same, but they use different technologies. So those guys, after a while, decided they will use Java for that. Java is perfect, fast, so they can do that in Java. And can you guess what other developers have chosen? What? Tell me. Python, not. Almost. So they've chosen Java ++. I will show you what the ++ is like, but more or less that. So, and by the way, I'm a very bad guy. I've stolen the code, so if you want to see it, the code is under the Aeroman Galacpizza, and later I will tweet it, so you can find it on a GitHub. The whole code that will be used in this presentation is on a GitHub with story and everything. Okay, so the normal guys universe, Java guys, decided to describe the domain, and they quickly come out with this class. Class order, I don't know why it's realizable, but they found, okay, order must have ID. I don't know why, but the planet, by the way, so our address where it's delivered is only a planet, because, you know, planets are very small. If I'm ordering pizza, I tell, bring it to Earth. Earth is small. If it was Jupiter or whatever, that wouldn't be the really functioning, but, you know, nobody really eats pizza on Jupiter, so it's not a problem. On Earth, it's mostly small planets. So variant and size, as you see. And by the way, you see one thing? Public final, no getters, no setters. It's cool. In Java, even in our galaxy, you don't have to use getters and setters. Who is using getters and setters? Oh my God, you are so 10,005. Really, it's not needed anymore. What's the reason for that? It's so much better, this. But okay, that's not the most important part of the talk, but later we can discuss about it. So then they describe the size, variance, enum. That's simple part, okay? Then they are thinking about the behavioral part. What kind of services? So from the customer perspective, that would be one function, place order to which planet, which variant, which size. So one pizza, I order one pizza. If I am customer, I use this function. If I am doing the backend, if I am pizza boy, I take orders from that planet, so I mean, it means like, give me the list of orders to one planet that I should serve right now, and maybe empty these orders for this planet. And then the second, for the supervision, for the domino, the businessman and his wife, is count standing orders. How many are there? Long. Very easy. So they even like, you know, they like design, so they created interface that joins 2 of them, Galac Pizza delivery, Galac Pizza orders. I don't know why they liked it this way. Okay, crazy guys, developers. So now came the point they wanted to implement that. So I would do it rather quickly. You don't have to follow every step. It will be plain Java solution. How to do that? So they were thinking how to store in Java orders. So they come with idea, maybe for each planet with this string key, we will just have a list of orders. And it worked. Who knows, who thinks it's a cool idea to store orders like that? Okay, cool. Who thinks it's not that perfect? Okay, they found out if you store a list like that, you have a problem because this list might be not yet existing, it's a null, or you have to like somehow encapsulate, so it's better if you provide here an object, planet orders, that encapsulates lists. It's always better because then you know what to do with each planet. So they created another class called planet orders. So if you look at it, it has a name of the planet, list of orders, basically it's encapsulated. To make what you do with a list limited. You now can't do everything with the list, like, I don't know, clearing it, whatever, from outside, only the things that are out, or maybe assign order, like here. Cool. By the way, they provided another method I will describe later. So then, how do they create the place order? So very easy. So they have one sequence, that's for the ID of order, so sequence is long. Then they increment this sequence. And then they create order, new order, then with constructor, and then they have everything. Then assign order to planet. That's a method I'm going to show you in a moment. And then basically that. And then comes this, the problem is this code you don't see in the back probably, so come here. So comes assign order to planet with order. And what is here, maybe orders compute if absent. So right now, raise your hands. Who knows compute if absent on a map? Okay. So who is a Java developer here? More people. Not everybody. Cool. So one lesson. If you are a Java developer for a couple of years right now, maybe a year or more, and you don't know that compute if absent exists, it's like maybe you are wasting a little bit of time, because mostly what you have, you are wasting your time, so it's good to learn it. If you have this pattern, I have a hash map, I take something from a hash map, but it's null, because nobody yet stored anything under this key. So I have to init it with empty planet orders, and then do something like that. There is a pattern for that since Java 8. Compute if absent means I want to take this planet with this key, order planet, and if it's nothing there, please insert there the initial value, new orders with just planet orders, so with empty array. And then after and then I get it always, so I have never null here. I got always created objects. I don't use any if was null, then please create new, then put in the hash map. It's all there with one construction. It's so nice. And then you can call this assign order. So simple. And at the end of they created this thing. We will refer to that later. Increment and get and atomic long. So one thing you might wonder why they had used long here and here atomic long. Who knows what atomic long is? So basically, it's for those that you know, it's a long that you can reuse between different threads safely. So they have one long that they use, this is not thread safe, and one long that it's thread safe. And then basically, after putting an order, they increment this. So 2 increments happening, but okay, whatever. There is a reason for that. And the thing is how to implement these Turk orders from best planet. So how can we find in our hash map which planet is the best one? Which planet has the most orders at the moment? How to do that? The first solution they did is like take all the values from the hash map, sort them, and find. Well, that solution was working, wasn't very efficient in terms of performance. Like if you have 10,000 of orders to different in this hash map, really finding the best planet, sorting it, it's just inefficient. Is there any better way to do that? What? So the idea might be that there is a kind of a structure in Java that whenever you put an object there with some, maybe with size or whatever, it automatically sorts it for you and makes it efficiently. You know what is this? What? Yeah, there is another. Okay, I could use this, but that is with a key. So the problem is, what's your key? What is the other? Okay. What about priority queue? Does it though? Okay, in my case, okay, I didn't describe. I wanted specifically to have operation, put something there, and take the best one. It's exactly what priority queue makes best. Take the best one is the best. So it doesn't really. If you want to see the order, all the elements, priority queue is not the best. But if you want just to take at the moment the best one, it's exactly what priority queue does the best. So who has used in Java priority queue in a couple of last years? Okay, that's interesting, you know. Oh, okay, so this class is there for ages. So, and then what we simply do right now, by the way, it's a kind of a manual index that we have. So we have our data here, all the data is here, but in order to make something faster, we create that separate index, priority queue. And what we do here is just at the moment of this assign order to planet, we just put these planet orders there, but it would be wrong. Why it would be wrong? Who knows why it is wrong to put in this queue these planet orders. And then if the planet's orders is sorted that the planet orders with the most orders, so with the size of the orders wins, in the sorting, why it's wrong to put it like that? What? So, comparable is implemented. What is the other problem? So, the problem there that is described, these planet orders, as we do here, we assign order to planet is mutating the order. So it means that I've put the planet orders with 5 orders into the queue, and maybe a couple of seconds later, I modified this object, so it doesn't have 5 orders, but 6, So it should be, in fact, in a different position right now. The problem with priority queue, the objects cannot move without priority queue knowing of that. So basically, in priority queue of Java, if you put something there, it should never later change the sorting. So the fields that affect sorting and compare to. So you can't do it. Okay, you could, it would work, but it would work stupid. So there is a way to avoid that. Let's create a kind of wrapper, which would say, at the moment I was putting this planet with 5 orders, it had 5, and will never, this wrapper is immutable, so you would have 5 forever, and whatever happens with the planet. If the count happens, when just a second later comes another order, then I will have a second entry with 6 orders, but the one with 5 stays there and doesn't change. So it makes our priority queue behaving well. That's the wrapper, it's just a wrapper there, and what we have here is preserved final size, nothing more. It's easy. You can compare to, it's easy with, with this size. So it works. By the way, take orders is implemented like this. It's really, really bad here, but I did it to make it faster. The guys were already prematurely so I did it. The guys did it. They were thinking about making it faster, so they just used null. You should typically not use null before you really need it, but okay. That's the thing. So how is take orders from best planet done? Let's go to the point. They basically do it this way. We take from this priority queue, let's take the planets. If it's not null, and if it's not emptied because it was already served, then return it. By the way, this method shows you something optional. We use optional here, not like priority queue that is returning null because it's year 2015, or sorry, 2017. In our galaxy also, never use null if you are not fighting for cycles. Mostly you never fight for cycles. You mostly want to have safe business logic, and in Java, safer is always not to use null anywhere. Use at least optional or something like that. So they return optional, and then, so they find the best planet, and after that, they, for instance, if the planet is present, so they found something, what we can do, we take orders, and we return that. Otherwise, we do collection empty list. By the way, who knows how to write it better? By the way, I'm talking about optional, not about logic. Think about how you use optional. Who knows that this code can be written way better? Okay, more or less. So, who other idea? What to use? What? Okay, yes. So basically, I tell you one hint. Whenever you, okay, so first hint, the most important, never use null. Never, ever use null. Use optional, and optional is only useful, really, if you never use optional get. So if you see somewhere optional get, so it means someone made a mistake, made the code not optimal. So this code above is more or less the same like this. Planet opt map, it means, what is this? We take planet orders from this method below, and map means, if I find the planet, please do with this. So I am, maybe from this atomic long, I am subtracting the number of orders, I am delivering, so I am removing from the queue, whatever. And if, then I have map. Map makes me another optional, and then I could use method or else. So if nothing was there, then I return collection empty list. Why it's better? Basically, there is no if here, and there is the tape safety, because if I have if, maybe I've implemented only first part, but I forgot about else. What it does, if you do it this way with map, please remember this, you will never forget about doing the other part, because compiler will complain, sorry, but you have to provide something, like list of orders must be something, so at least you will be forced to maybe provide collection empty list or something. Okay, so that was the short lesson about optional. Remember that, because if you find like optional doesn't bring anything to you, it's like only makes it more complicated to the thing you are doing with null. Mostly it means you are not doing it correctly. You are not using map or flat map in optional. You are doing optional get. But okay, so with atomic length long, on the other hand, if you are, for instance, counting standing orders, it's now very easy. We have this orders total, which is incremented with the put order, decremented with the take orders. So it's very easy. Here we can use get. This is other get. So we have it done. So they had it done. And the thing is, who thinks that this is not a really solution to the problem? That something is missing there. If they implemented whole put pizzas, take pizzas with a hash map and priority queue, what is missing there? Okay, reporting was required. That was the only reporting needed at the moment, nothing more. So what's more missing? Oh, okay, you see the testing was done. Okay, but they were very fast. They test later. On the GitHub you will find tests. So what's missing? Persistence, okay. Another point, what is maybe smelly here in this code? I already pointed one. So basically two things are smelly. Concurrency and persistence. So persistence is easy. So what if the computer stops, if you restart the system? Where are all these perfectly nice orders in the hash map? Where are they? With concurrency, the one issue is why I had one long that I haven't synchronized at all, and one atomic long. Atomic long was like looking like maybe it was done right, but the other thing was done with just long. No synchronization, no volatile, nothing like that. So might be wrong, but then, you know, they had like one senior developer which is totally set all the time, but he said to them, that's not a problem. We'll use a small magic. You know, I'm a guy about magic, so by the way, I mostly point all the magical parts with this. Sorry, it's not somehow readable on the screen, but I will show you. So basically what they did is they had previously implemented Galact Pizza core, so the implementation in plain Java with hash map and the priority queue. But what they did, again, in the next step, is they only used some library called Arrowman, but it doesn't really matter. Okay, so it matters, but it's a very simple library, I promise you, but brings something like persistence controller. It's basically container. So they say it's container for my Galact Pizza core, but it's a container that brings magically persistence. It's not that magic, I will explain you how. So here they started where they say where is on the disk this thing. That is a little bit of magic how you build it with a builder. And then basically they had in the Galact Pizza core 3 methods: place order, take orders from a file, count orders. So what they did is they delegated all this method to this persistence controller with Lambda. So whenever someone wants to place order persistently, they do it on this controller, passing a Lambda, core place order. So it's basically passing this Lambda what to do. Of course, one can write here more complex stuff, but basically it's, in this case, very easy. We just do the same thing. And this is the magic point. You see magic here. What it does, it simply solves two problems. It stores this Lambda in a log. It means someone in this moment was placing order to the planet with this variant, with this size, and it stored in some kind of log. Like you know, you've seen Apache logs, HTTP logs, someone is posting something. So let's imagine things like that. It's stored somewhere on the disk. And here, for instance, take order from this planet, the same. Somewhere in the disk is stored what was done. And if someone is doing a query, basically it means it's only from farm, handwritten query, because it's only delegated, nothing is stored on this, because it's not interesting if someone is only asking. We don't have to write that someone was asking about it. Because, okay, I will tell you later, so it's important. And basically those two steps, writing this Lambda inside of this method, solve the persistence and concurrency problem, mostly. Concurrency not fully, but mostly. And they said it's done. Later I will describe why it works. So it's done. And they said we finished. So let's take a look at the alternative universe. We do it quickly because this is the universe I bet some of you know. Oh, sorry for that, but really it's not readable. I have more code. So basically the other guys started with doing order. You have to imagine this code. Sorry, I wasn't prepared for such small resolution. They have order. And they basically did the same stuff like final string planet, so it's more or less looking the same, but then they had to put a couple of stuff like named query, table, whatever, all of this stuff. The most funny thing they put here is protected constructor defaults. Like, you know, when you have object that has like 5 attributes that you make final, you can create constructor with these 5 properties and it's done. But if you do it for Hibernate, it's funny. Maybe Vlad, correct me. But previously,
it's not Hibernate, it's for JPA.
Okay, for JPA, you have always to provide, for some funny reason, default constructor. So never in this code, the guys were thinking about creating empty order for unexisting planet with non-existing pizza of non-existing size. But for the sake of JPA, they had to implement that. So it's like, I'm normally in the code, whenever I'm forced to do that, I put some, swear words or whatever. But okay, this presentation I couldn't. But apart from that, this code was very similar to the previous solution. But what was the solution here? They want to write Java guys, but what they did, in fact, was like a lot of SQL strings and the magic, and the things like that. Okay. So if you look at the size and variant, already Hibernate JPA is good enough to do it very cleanly. And they connected to after putting some XMS, they connected to MySQL, because of course that's the best database that exists in this galaxy, far away. And so they've seen it in the table, so they are happy, oh, it's in the table, it exists, so great. So then they were starting to implement that, okay, and maybe how you, so, I won't describe you putting into table, you will find it in every tutorial to Hibernate, how easy is that. But how, for instance, implement taking the best planet? So the first solution was like from orders, select and count and group by and order by count desk. That was the solution that was natural, but it wasn't very performant. You know that. So there are different solutions for that, but after trying a couple of stuff, they found out they will create manual index. So the other table that will store the name of the planet and how many orders are for each planet. So it's kind of manually managed index under other tables. So very similar to the thing you've seen before, manual index, like the guys previously in Java. So they basically, after putting orders on some planet, they also increment this counter here. And they basically have the second table with index on that. It should be faster. So yes, they played with that. It was faster solution, so they lived with that. So now comes the thing, how do you work with transaction and stuff of that, stuff like that? So they didn't use Java EE or Spring or whatever. So because in this galaxy it wasn't that popular at that moment, so what they did, it's kind of manual transaction management. So who knows Spring? Who knows Java EE? So basically you know that in order to have a transaction, you typically put this transactional attribute or nothing because there is a default. Those guys, instead of putting the annotation here, they put only this call here. This is this run in session, and then they have put lambda. So it's the same, in no matter how much code, okay, they have one brace more, but it's this. And they then call the database code, like with a putting a Hibernate session and then doing what they need, like saving object in Hibernate session. So we might take a look at this run in session code. So by the way, it's written only once in the system. Somewhere in the system, you can even have libraries that have this code. What we do, we start Hibernate session, we begin transaction. Then what we do, as a parameter, we get the command, the thing to be done, the lambda. So we do how we were called, and then we commit the transaction. If something happens, we roll back the transaction. By the way, they had a very specific need because of to make something faster, and they wanted to even retry transactions. Sometimes they had a constraint violation exception. There was a case for that, and in that case, what they do is simply they roll back and they retry the same transaction the same code in a new transaction. That's something that it's not that easy to write if you have transactional attribute. How do you retry? By the way, in new Java EE specification, there is possibility for that, but it's like with this approach, they are in full control and can do it. By the way, it's not even that magic. I put this magic wrongly. Okay, so I won't describe this all. It's like the code you would see. You see this is a little bit of code, but with SQL that is readable, it's not that complicated. So, and by the way, the lesson for you, you don't have to use all the time annotations, because more or less with the same amount of code, you can use lambda syntax and call with functions. So the same is with security or validation or caching. So what they did to do is like Hibernate config. They spent a lot of time on MySQL config and initialize MySQL ini to make it a little bit faster. And okay, after one day of coding, comes they implemented everything. And comes the reality. So I can't present you reality. So on a GitHub, there is a simulation of real galaxy, real life story. How the simulation works, there are 4 threads doing place orders, so simulating all the customers. Without any pauses, they just put orders one by another. There is 1 thread representing Pizza Boy that just takes orders, and 2 threads that are doing this querying, count standing orders. There is a simulation written for that. I spent a couple of time making it behaving, I would say, constantly and properly, so that nothing is really pre-optimized by JVM too much. So for instance, there is a lot of validation put there to make it really meaningful. I also made some tests with JMH framework or whatever, but there is all on a GitHub, and you can see that. There is a simulation of what the guys did on the thing, so there is even some JVM warming. Okay, let's skip that. If you are keen on benchmark, I really like to, if someone, because basically I can prove you, every benchmark you see is wrong. Just, it only takes time to find out what's wrong. So this is probably still wrong, but I already fixed a lot of stuff, so it would be great if someone is keen on that to find something all other wrong. Maybe you will have different results, but the results I have in this benchmark are very similar to the things I have in the typical project, like productive. Okay, basically it's hard to compare 2 different words, but mostly this is the thing that people observe. So in a normal universe, in other universe, process orders. Remember that was the reason that the requirement was to have 10,000 orders processed per second. So those guys on the normal universe measured 40,000 pizzas per second. Cool. Although guys with this other universe had like 600 pizzas per second, if you work with this kind of technology, it's quite okay result, by the way. It's not really bad. It's like only the difference is like, this is the typical solution. By the way, I've worked for a lot of banking insurance projects, and we are happy having like 20 transactions per second. So of course, in this universe, the businessman was happy. In other, he was like kind of angry, instantly bigger, you know. There was a problem. But looking at the orders, here comes the funny thing. How fast do you look at the one long? It's like, if this number, I had to verify it, but it's basically like how often you can verify long from memory on the modern hardware. It looks incredible, but it's in fact physically possible. Of course, there is a huge difference. On the other hand, and by the way, it only worked on one MySQL version. On the newest version, I can't really get it, but okay, nevertheless. So, of course, again, happy and happy, you have the lesson, yeah? Okay, by the way, those guys put it on this exact laptop, so not even that. That's old machine, basically I had this, and it worked. The other guys were searching for servers that make it faster. It was kind of hard story, but couldn't really make it faster. So, by the way, those guys tried to find out if they can make it faster, so they run very basic Java profiling. If it's all Java, it's easy to profile it. There are tools for that. NetBeans has a particularly good profiler, very easy to use. Okay, profiling is not always very easy. It's mostly not that easy, but you can learn that. And they found the bugs. They could make it faster, by the way. The other guys were looking at the problem and quickly found out the problem is really communication with MySQL, so they were like using MySQL tuning script. By the way, there is such that does a lot. They were looking at MySQL ini, a lot of stuff. They found that there was one index missing, a lot of stuff, and still they needed lots of SQL. And after a while, those guys got better results, like 60,000 pizzas per second. Those guys were almost twice as good, but they're still not there. So, in this case, the guy was angry. In this other case, he was angry too, because you never really work on making things better if you already reached the goal. It makes no sense. That's a lesson for you. Don't do that, because you can break something. Okay, but after a few days of operation, what happens? In normal universe and other universe, by the way, happened the same thing, because the fork wasn't that, long ago, so there was a power cut. No power anymore. And the guys even seen that. You know this. And the guys from this universe, oh my God, we trusted our senior developer that something will be persistent, but we never tried it. Oh my God. The other guys were like happy. Oh my God, we have all in the server, in the MySQL, it will be stored, not a problem. Okay? But then the guys on the laptop seen this. Oh, it runs on laptop, so we have hibernation. The memory is preserved. You know, memory is persistent. By the way, hibernate. It's almost like the label. So, you see, RAM is persistent. Can't be better. So, but after a couple of other days, there is another problem. The businessman comes and says, he don't trust Pizza Boy. Maybe he's not delivering the pizzas to the place he wants to be, and customers are angry, and he doesn't know. He wants to double check if the guys delivered the pizzas to the correct places. So he needs a report. Someone said reports before. Okay, cool. So he needs a kind of report to know where the pizza boy delivered the orders, where they should be delivered. Okay? So in the other universe, they said, okay, that's cool. We'll not delete orders from the orders table anymore. We'll just mark them as deleted. By the way, that's a lesson number 1 you learn with a database you never delete. You know, it's like insert, update, delete, forbidden, never. So mark them as delete, and that was the solution. Very simple, not a problem. Those guys said, okay, you know what? So we have this log of all operation. We'll restart this log, and right now, we'll not only modify orders after every delivery, we also store in SQL database the orders that were processed. So because for reporting we might use SQL database, because these orders, the archive, what was processed, it's not needed anymore. It's like archive data. If you have some data that it's not really needed, it's not hot, it's the perfect fit to database. If you have something not needed, put it into the database. It's the lesson. So the system was restarted. After that, magically all the lambdas worked, but right now the lambdas had different code. That wasn't a problem. So right now there were exactly the same work done in the system, but only as a side effect, things were stored in the database, so the owner could see the result. And then they came and said, okay, so show me the results for yesterday. And you know, the guys from the other universe said, okay, sorry, man, till yesterday we were deleting. From now you can see, but the old data is gone. We were deleting, you know. Other guys said, we have like events from the start of the system. From the start of the universe, we have all that's happened. So we can restart everything. That's not a problem. We'll show you the data that in this kind of approach, you never delete anything because you have always all the log what was happening from the start. It's cool. So, okay, skip. So, yet another real world case, maybe one day he says, okay, this limitation that we have only Hawaii, margarita, and vegetarian is too much. We want to have more relaxed rules or more possibilities, like the guy puts cheese on one half, meat on the next half, and onion on the third half. That's the galaxy. So let's make it more flexible. And the guys here try to find object-oriented way to do that. So after modeling 20 tables, they find the solution for that with text feed. And the guys here may be thinking about the factory builder pattern for that, basically because everything that's serializable in Java, that's a lot, by the way, they can do. So they have freedom, they can have modeled it with fun object-oriented way, and they did it. So right now I am trying to right now summarize it. Those worlds were a little bit different. The differences was, you've seen that one was very fast, second was terribly slow. By the way, having 6,000 transactions per second is not as slow at all, but in a comparison it was slow. Here the whole code was in Java. Here the Java code was kind of, I would say, dull. It was really simple. The real part was in strings and annotation, which by the way, it is called stringly typed code. So here it's more strongly typed. This is the difference. Here the domain was very flexible. Whatever you can model in Java, you could do. Here it's you have to fit it in the tables. So people from this universe think in tables. If it doesn't fit table, it doesn't exist at all. Testing that, if you look at the code, testing testing Java code, which is plain Java, it's so easy. Even with this persistence, it's super easy. Even if we have this log, by the way, we are using it in a productive system, so think of that. Someone is doing on a test system a scenario. He's doing something, after a while finds out that this guy should have 200 euros at his account, but has 100, there is a bug in the system. So what the guy says, okay, let's analyze it, and the analyze for that is log of all the events. So we could basically copy the events to our test scenario and rerun this code we had with this test scenario, and put an assert, okay, the test is green if it's 200, and then we had like automatic test scenario without any problem. If you have this kind of lock, it's so easy. And here, of course, testing something with real database, if you have database that you own, you should test against the database. Never use mocks for that. Because if you mock the answer from database and then you put a query, what it really says you? It says you the mock is good, not the query. But okay, and there is one drawback here. If you look at the whole code in Java here, was kind of sophisticated. You have to learn a lot. The guys don't like to learn, would rather do this. Like, we just write 10,000 getters and setters and we are done. That's not a problem. The database will do the problem. Okay, so why was those words different? You know what's that? That's memory. That's core memory. That's from 60s. That's the last memory that you could really see one bit with your eye. Really, that's so cool. Of course, this was very expensive. It was very expensive. It was manually handcrafted, by the way. But then, well, it evolved every galaxy, and around 90s, so-called 90s, in those galaxies there was also something called 90s. Computer had mostly one CPU core. RAM was expensive, but not as expensive as this core. So like 100 megabytes was possible in a single unit, but disks were way bigger, like 20 gigabytes. But were, of course, way, way slower. But it means with 100 megabytes, you can't store that many pizzas or accounts. You can store them in 2 or 20 gigabytes. So there came a solution that will just do these things because we'll do things slowly on the disk, but we'll have a little bit nicer code. Let's pretend everything is object-oriented and have object-relational mapping, stuff like Java EE. Okay, I should put here, in fact, our RMs. And let's have it. Let's pretend we are like doing only things in memory, which is not really the case, but because this is a still leaky abstraction, but let's do this way. And it was working. It was really nice. It was the solution to the problem that at that moment existed. But around galactic year 2003, in a normal universe, RAM became cheap, and you could like buy gigabytes of RAM. So 20 gigabytes, not a problem. Even years ago it was possible. So computers had multiple cores. So it's like now, what it means, like every time you synchronize, it's like stopping. You have to think about multiple cores you have, all that stuff. And OEM developers started to realize that Java is very powerful, and they can use the hardware perfectly with Java, especially if they don't store everything always on this database somewhere, and when they just use a RAM, and maybe indices RAM, whatever, stuff like that, because it's not needed anymore. So they realized that because, of course, RAM was cheap and huge. In the other universe, there was a small difference. RAM was cheap and huge. Computers had multiple cores, and nobody realized that. Right? Because the fathers were doing it this way, it must be good. We don't ask. Why? It was working, it works in million systems, it must be good. We just do it. So, by the way, I don't say the other universe is a bad place, it's a perfect place. It's like database vendors and money are happy. Like, why not? It's like, we need money. So, application servers vendors earn money are happy because otherwise who would use application servers? Power plants are happy, the coal miners are happy because they have, they have to support all this hardware. Hardware vendors are happy. Basically all those guys are happy. You would love to bring them new Lamborghini, whatever. All these guys, they have kids, so you should take care about them. So only business complaints, but they pay, don't worry. So developers have a lot of stuff to do, like configuring databases. Oh, this is more complicated. It's not plain Java anymore, but it works. Okay, I had a picture which doesn't work, but okay. Oops. Okay. So, does it mean, on the other hand, that for developers' perspective, everything in this normal universe is so better? I don't say so. Basically, the problems that exist in both worlds are very, very similar. For instance, if you work with Hibernate JPA, you have detached objects problem. And if with this normal universe, the solution I presented, you will have the same problem. Transaction isolation, I always say it's like, there was today a great talk by that. Basic transaction isolation is partially a lie always. You have never perfect isolation, you have always some rules to that, and you sometimes spot it in the database. The same with this plain Java solution. However, here you have to be more careful, you have to use Java concurrency, but basically you see the same kind of problems. Testing, there is a difference. Testing here is trivial, there are other universes worse. Caching is like, whenever you want to build with database very fast system, you have to invest in cache. And it's awful. It always brings a lot of bugs. Here it's everything in memory. It's all cache, basically. So it's fast. You don't have to configure anymore. When it comes to magic, like in typical, Spring, Java EE database system, you have more magic, all of the code automatically stored in transactions, security, everything. It's like magic is spread everywhere. You just write getters and setters and the system works. You just can't find the business code. It's somewhere missing in the getters, missed in the mappers, I would say. Here it's like magic is very contained to a couple of lines when you may call this persistent controller. By the way, it's still not magic. It's very simple code behind that stores something on the disk and calls the code later. And that's, for instance, very important thing. If you spend like 10 years with database, modeling the system always to table, your mind is shaped like a table. It's rectangular. You start to lose all the possibilities. If you spend a little bit on time of that, you see that you can model things totally different. Like, why isn't my attribute not a string? Let's make it a function. Who of you has function as an attribute in the database? It might work, but it's complicated. Okay, so if you want to jump to the normal universe, well, now quickly how to do that. So you can read about this project. This is really great thing, Previler, very old. This is the idea how it works. A couple of years ago, I did this. Arrowman is basically Previler writer. I wanted to write something better than Previler, faster, but then I realized I really don't need anything faster. I need only better support for Java 8. That's what I did. So basically, it's a wrapper with a better support for Java 8, nothing more. Oh, basically, it's so easy that if you read how this works, you can do this with 300 lines, your own version. Just if you would like to write a lot of code, why not? It's funny, really. It's funny exercise. Then you put a dependency, and then you really have to remember that you put all the things. Whenever you have a system, let's put it into the one object, the whole state of my system. By the way, it's a root aggregate, if you know DDD, and then containing is this container persistent controller. Then build it. You put in which folder it's stored. And it's basically there. By the way, on productive system, I've shown you how funny it works with lambdas. On productive system, do not do that with lambdas. Make a full version with new class here. Why? So instead of writing lambda, do it the old way with class. Because serialization of lambda is stupid and more like a joke. So it works perfectly as long as you are doing prototyping. Prototyping, you are very fast, it is funny. But if you are going to production in order to not suffer later, don't use lambdas to do the full stuff. By the way, in typical system, you don't have like 1,000 on transaction. You have like 5, 6. So basically, every time you have like form with save, submit, you have one transaction for that. Not that much in every system, really. When it comes to concurrency, why it works? Basically because every time there is something inside of execute, there is only one writer doing this thing. It's synchronized, so there is only one writer at a time. So there was this long sequence with orders ID. So it's safe to have it as a long because maximum only one thread will refer it at a time, never two of them. So it's safe, as long as you are thinking about the write side, so execute. If you are talking about the query part, it's basically multiple readers. So if there is something shared between writers and readers, it happens like this atomic long, then you have to put it in the atomic long because you share something between readers and writers. So it happens. If you look at how it's stored on the disk, you typically has a lot of files like this, journal, snapshot. What is a snapshot? Who knows? So if you for a year, run this pizza, Galaxy Pizza, there are a lot of events. After the year comes the power cut. Then you restart the system. And right now you have to process the billion of events. Might take time. So the solution for that is to do regular snapshot. It means let's snapshot the memory, the object that we have, and if the system goes down, then we start, we look for the last snapshot. It's automatically done by this Previler, and then we load this snapshot and all the things, events in the journals later. So, okay, problems. If you think the memory is limiting you, you don't have enough RAM, right now you can really order servers with terabytes of RAM. So, by the way, it means mostly if it fits database on disk, it also fits RAM. So for lots of things. So data migration is not that big big problem. By the way, it's easy to redesign domain. So your object, the best is to never change your events. So in a real system, I even have I would have place order v1, place order v2. It really happens that there are systems with that, because if you once written the event, it's basically best, if you later, for instance, need additional data to that, like additional fields, it's best to leave the old version there and write a new one. It's not a problem, it works like that. And then it's even the migration is easier than it would be in SQL. You just delete all the snapshot, reply everything, and you have new version because new rules apply. So once I implemented the game, and I have made a mistake in rules, so that basically the record table, who was the first, was broken. Yes, okay, so I correct the rules, delete all the snapshots, restart, and now the records table is okay. And then the guys complained why they were first and now second. You were first because the rules were broken. Okay, it's always hard to explain this kind of stuff. So transactions, if you think it's not transactional, it is transactional. What basically happens if you inside this transaction controller there comes exception? Then what the controller does, oh, there was an exception while I was applying this lambda. What I do, I don't store this lambda in a log. I remove it from there. So, and then I restart the system without this lambda. So it's like restart again. There is even a pattern implemented for that with a second copy of objects to make it faster. If you fail often, then you won't really do restarts all the time because it will be with cloning a little bit faster, as long as there is a cloning working there. The very bad part of that. In order to be efficient and safe with that, you have to know Java util concurrent and how synchronization volatile works. And that's the thing. Not a lot of developers know that. And basically, you have to rely on immutable data structures, which is always the case. If you have to use Java list, array list, whatever, what is in Java util? Think of it as a very low-level, fast but low-level library. Use something that is more suitable for business. In typical business, you don't really fight for cycles. Use immutable list. For instance, previously it was Guava, right now it's Waiver. Who knows Waiver? So I made it big. So I would say Java library number 1. Whatever you do, first do it with Waiver. Only if you fight for a cycle, for performance. That's not often the case. Then think of Java util, list or whatever. Here is way better API for lists, hash maps, whatever. And if you use that, then you don't suffer that much with these problems with concurrency, with this persistence I propose. So, okay, replication failover in this is, I skip this part, I don't have much time. So, what is this library I propose? If you look at this code, it's I call it poor man event sourcing CQRS, if you look at this. Who has heard CQRS, event sourcing? So if you don't know and you don't want to invest a lot of time on finding how it works, if you try this solution, you exactly see that's the one very simplified implementation of that, with just RAM projection and very simplified command event model. Okay, if you're looking for something more enterprising, this code is really, this prevailer error man is a couple of hundred of lines of code. It's a very simple solution. And it works for me perfectly for systems that I don't have to promise someone it's very professional enterprise. If you look for something enterprising, there is a thing called Lagom. Who has heard of Lagom? Really great library this is basically akka but for Java. Akka persistence works on the same approach. That is the same way it works. CQRS generally, so there are great talks from Greg Young, Polyglot Data, why CQRS and event sourcing is so way better than typical database. And by the way, if you use event sourcing, never store the events in SQL, because it's stupid. That's my lesson. If I'm implementing systems this way, I already had sometimes a feedback, it doesn't work because I press save and immediately it gets there, so nothing was there. So I had to put really in UI some delays to make people convinced that something was done in the background. Okay, some people say that basically what I'm proposing here is just another database, but there is a really huge difference in how you work with that. Here I'm modeling the events more than the domain. I'm storing the facts, what happened, so events, not storing the state. I'm sharing the facts, not sharing the states. And I have less magic and, okay, that's it. So to the end, if you are interested in that, it's in fact so simple that it's very hard. If you spend 5 years in database, first system you try with this will be stupid and you will fail. So try on something small first. And then you will learn a lot. If you try that, and you will maybe like it. Like I tried it, like 10 years ago, and my first system was a nightmare, but then I realized, oh my God, this is so cool. And then you can drop DB, basically that's my icon here, drop databases, you don't need them, it's so 90s. Drop application servers. If you go to Technology Radar, you know what the Technology Radar, the page about trends and things you should avoid. Application servers are for like a couple of years already there. Like Tomcat WebSphere, it's just not needed anymore. The reasons are you have them, they are not existing since years. Drop annotations, I have another talk, why annotations are harmful, why the magic is harmful, reflection, whatever, and you can learn Java algorithms if you like learning and you like this stuff. And then finally you will be able to like use all the power of RAM, really like do on one notebook system that are faster than your whole server room, the whole cloud of Amazon, because you do it wise. Okay. Okay, it's of course depends, but that's the solution I've seen. Like I have a couple of systems, none of them is huge, which I must confess. Basically, whatever you do with that is always small, somehow, never grows so big. And I have some systems that work for years on very small machines. They are cool, nothing wrong happens. And really, I feel that I'm using the hardware as it's supposed to be. Like, the systems are so much faster, like they're typically 100 or 1,000 times faster than SQL solution. So why invest in hundreds of servers when you can do it on one old notebook? Okay, thank you very much.